Okay, let us go ahead and get ourselves started with session 12 of 128.228. Today we're going to continue talking about this whole idea of doing bigger buildings and how we actually start to do building models to accurately reflect all the architectural elements that are part of the shell and the core and the interior kind of elements of the building, as well as the structural models. So we're going to keep on moving along two different paths simultaneously, kind of hopefully giving you a lot more detail about kind of the architectural side as well as the structural side. So as we get going, today I'd like to go ahead and introduce you to assignment 4, so you have the context of which you're going to be working on as you apply all of this. Again, this is something that you have a fair amount of time to work on, but don't go ahead and kind of just put it on off, because I think if you've talked to folks who've taken the class in the past, this is the assignment where you have a lot of rope and it's easy to go ahead and either use it to your advantage or hang yourself. It's one of those things you have to be very careful. Miss Mia, what you got back there? Actually, we don't have anything in there today. Nothing in there for you today. A very good question. Okay, let's go ahead and let me get started by just thinking about the assignment itself. Or the question for the folks on video was, are there any folders in the session 12 folder? I'm probably going to use something that was actually in the session 11 folder, if that makes sense, just because I didn't get to it last time. But we will go ahead and kind of introduce that when we need it. Okay, in terms of getting going with the class today and the assignment, let's go back over to the course and go over to Canvas, and we'll pull up the assignment and take a look at it. Okay, so the assignment is the workspace of the future, and we'll go ahead and kind of read the brief about that. Notice that this assignment actually has 45 points associated with it. So if you're keeping score, that's kind of the biggest thing we've done so far. It's actually sort of as big as 2 and 3 put together. Okay, that's kind of appropriate for it because you're sort of doing several different things as a piece of all this. Notice also that this is due, where did it go? Where's the due date show over here? November 15th. Okay, November 15th, I realize, is the Wednesday before Thanksgiving. Okay, I know that's a Wednesday. I know it's the Wednesday night. I hate to make anything due the Friday night before Thanksgiving, because most of you are going to be off heading on vacations and stuff like that. So try to get it all done by that Wednesday, and you'll be good. It's even before any Thanksgiving parties that might be going on. Hopefully you'll have a nice kind of clean introduction to your holiday. Again, there's always the flexibility that if you don't quite get it done, don't panic. You can extend a little bit, okay? But if you can try to target for the 15th, that'll actually just make your whole holiday experience much better, okay? So, but again, the 15th's a long ways from now. Not too awfully far from now, but there's still a fair amount of time to get everything you need done, so I don't think that'll be much of a time issue. Okay, let's go ahead and just take a look at the brief. Kind of see if we can just walk you on through this. Okay, the idea is you are going to be creating a commercial office space. It's a space which I sort of think of as a workspace for the future. And let's kind of think about really what we have in mind. The idea is you're going to create a multi-story building, a commercial office building for somewhere here in the Bay Area. You're going to design a simplified structural framing system to go with it, and your focus is really on just trying to develop something in a top-down approach and quickly modeling the elements of the shell as well as the structure. So this is not a detailed assignment. This is kind of a high level, kind of get your head around a building and try to come up with some initial stuff quickly. Okay. Often, we talked about this last time, we start out with a top-down approach because to try and really to come up with several 100,000 square feet of space bottom up, really, you know, it's hard to do. It's helpful to have an overall organizing scheme and then kind of subdivide and take the space down that way. So we're going to go after that way. Once you decide on the overall shape and form, we talked about that last time, a critical first step is to really think about what the structural framing system might look like. You know, often when we do the building modeling classes, we sort of do the architectural stuff and we kind of ignore the structure, or sometimes even architects will design an entire building and say, oh, structural engineers will just fit a structure to make it sort of work with that building. And we're going to try and do it just really much more hand in hand every step of the way. So from the very beginning of having an architectural concept to start thinking about what the structure would look like, because the best buildings really marry those two things very, very nicely, and they work very integrally together. Okay, your background for this assignment is your client, a fast rising social media company called Twitbook, is asking you to propose a commercial office building to meet the needs of their employees. Okay, they have a young workforce. They're looking for a very dynamic, fluid workspace that's going to encourage those informal hallway meetings, that spontaneous collaboration, all that stuff that happens that, you know, just really encourages people to kind of come up with really high power, high energy products they're putting out. Okay, along the way though, you're supposed to also be thinking about their employee well-being. It's not only about their working needs, but it's really their lifestyle needs, because sadly, a lot of people kind of live in their office, or a lot of their life is centered around their office. So the idea that it's not just a workspace, but we actually have to have good places to eat, we might need some good places to play, or to get a little bit of exercise, or just really take care of our lifestyle needs. Okay? And you might think about a big internet search company somewhere down the peninsula that actually has a very similar approach to this in terms of the way they create their spaces. Okay, your design task is to come up with about 150,000 square feet of usable floor area. And when you get into that, you realize that's not a huge building. That's a building that's probably, it's a little bit smaller than the Y2E2 building, just to get a sense of the size of that building. Okay, so you're not building a Salesforce Tower, you're not building a huge something or other. You're probably building something that's more on the order of 2 or 3 or 4 stories tall, something like that. Okay. That just kind of gives us that amount of space. You want to propose workspaces, mix of walled offices, cubicles, open workspaces. Be thinking about the way kind of people work today, and do they all need separate offices, or do we work better in large collaborative spaces? Or, you know, there's this whole notion of how work happens now. A lot of it happens in coffee shops and places like that. It's sort of a more informal environment where there's a fair amount of kind of distraction, but you actually can kind of focus in it. So people are a little bit different about their philosophies. Many spaces that are created now have no offices in them, and you just kind of go in and check in and hopefully find a place or a table to work or something like that. And some people are comfortable with that, some people aren't. It works well for some things, but we still need meeting rooms and things like that. You know, there's some places where when clients come in, you just need to meet with them. And it's nice to be able to reserve a space and say, we really have this space at this time, and have a whiteboard and things like that to work with. Okay, but there's also, you know, informal collaboration spaces. I'm a big fan of whiteboards. So I never do it in here because I'm always on the screen. I love whiteboards. So if you put me in front of a whiteboard with some markers, I'll just go crazy and have a big collaborative kind of session. So having informal spaces that have, you know, couches and tables and whiteboards and spaces where you can just drop into a discussion really quickly without necessarily booking a meeting room is kind of an attractive way of working. Okay, should be some sort of a cafe space where you can get some food or some coffee right in the building. And again, you don't need to be thinking about a 4-star restaurant, you know, something like more like Coupa, just something simple where you can grab a sandwich, a panini, a salad, grab some coffee, and just, you know, take care of some very basic, you know, kind of eating needs, but also some space to sit down, because a lot of times, as opposed to sitting at your desk, it feels good to be hanging out in that coffee shop environment. That'd be good. Oh, there's probably going to be some informal kitchenette/lounge spaces placed throughout the building so that everyone doesn't have to go downstairs. You might just have kind of a coffee station and some treats and snacks and stuff like that near a whiteboard space upstairs. You can think about how you might scatter some of those. Okay, you'll also want to think about some amenities to support employee wellness. You might have a small gym, like a little workout area. You might have a locker room for the bikers or the runners, or even a daycare center for people who might have to kind of take care of their kids. And running off to pick up your kids at 5 a.m. or 5 p.m. is a really hard thing to do in the Bay Area. You know, it's a really tricky thing to make happen with traffic. So these are all really just ideas. You don't have to include all of these things. You should include some of these things, but ultimately you're proposing something that you think is going to be a good workspace, okay? And you might have other ideas about what you think will be a good workspace that aren't on this list, and feel free. You know, this is all just here as food for your design creativity, okay? But don't view it as an exhaustive list of what you absolutely have to have. It's kind of just sort of like suggestions just to get you thinking. Because although it sounds like a lot of space, when we really start allocating it, we eat it up pretty quickly. You know, it's, yeah, 150,000 is not a huge amount of space. Now, a general principle on most big buildings is that in addition to the main spaces, the spaces that we program, there's also a fair amount of unprogrammed space. And that's just all about, there's a lot of infrastructure and utilities that doesn't really show up on anyone's spreadsheet, but you sort of need it. Things like hallways and stairways and restrooms and mechanical rooms and copy rooms. They don't really belong to any specific department, but you still need to have them. And a good rule of thumb is typically, on most buildings, like in a university building anyway, that buffer we add is around 20 to 25%. That just gets left over as in between spaces. How that'll work into your equation is if we're talking about creating about 150,000 square feet of program space, if we added that 20 to 25%, you'll get up to around somewhere between 180, 190,000 square feet if you allow space for the stairs and the hallways and everything else. So your total budget is actually down there. Okay, you actually have that to work with, because especially in an open plan office, the hallways sort of blend with the workspaces pretty easily. Okay. Now, not only you're going to go through and create your architectural concept, the idea is we want to start thinking about the structure. And if you don't have a background in structural engineering, we can give you a lot of help in this area. Many folks in this room and in this building have a very good background there who can help you. In the same way, I should offer the same thing for all my structural engineering friends. If the architectural design task seems a little bit daunting, we can get you some architectural help in terms of how to lay this out. It's really coming at it from both sides. But we do want to be able to think about the columns, the beams, the floors, and just the foundations. You know, we're not going to do a complete lateral analysis and put all the shear walls and all the bracing in. We're not going to do that like we would if we had more time, but at least to sort of think about really at a high level how we're going to frame up the floors and keep them from falling down is kind of a good thing for us to plan, because as we go through and we think about these big open span spaces with all this glass that feel very exciting, you typically need some columns in there somewhere to make that happen. So we just want to think ahead to what that looks like. Okay. So questions about the program, first off. Can you get your head around what this sort of space is, the type of people? The type of people who are going to work at it are people like you. It's like, think about what you would want in a workspace. Because I think you sort of typify the type of workforce that they're trying to plan for now. Yeah?
Are there any site design or landscape requirements associated?
No, for this one, we're giving you an open field. Okay, so picture, down in Mountain View or something like that, they have all those huge, relatively flat plots of land where they're building things near Santa Clara. Okay, yeah. Picture you have a fairly open site. There's no constraint on you that way. Okay, but you should think about how you want to orient the building, because that could be a consideration. Yes?
Sorry, how much should the footprint be of the building? Is there any limitation?
We don't have a limitation. Let's say, for example, if it was 180,000 square feet altogether and it was 3 stories tall, that'd give you about 60,000 square feet as the footprint. But you have room to spread out however you need.
So you can make it high-rise and maybe less.
Yes. Yeah, no worries there. Although, just given the practical realities of the Bay Area and the airports and things like that, I'd probably stay, I'd stay less than 10 stories. I think for these type of buildings, I'm more on the order of 3 to 5 is probably closer to what most people are doing. Although, in Santa Clara, the bigger ones are now like 8 or 9 stories tall. Keep it less than 10. Okay, and just given the size, if it was much higher than that, it would just be a very skinny pencil or something like that. That wouldn't probably not be very functional. Okay. Questions about the program? Any others? No? Okay, so just wrap your head around that. You got some time to kind of think about that. As we go through and work on the assignment, there's no specific starting point file for this assignment. Again, you have sort of a blank slate to work with, but we do want to make sure you use the right templates. So as we're doing our architectural work, we'll want to make sure we use the architectural template. When we're doing our structural model, you'll want to make sure you start with the structural template. There's just some slightly different things that are loaded into that make it a little bit easier for us ultimately to do the structural analysis on your model. If you forget about that and you end up starting in the wrong template, not to panic. We can always go ahead and transfer things across and get the things in there. But in general, your life will be a little bit easier if you start with these two different templates, because you're really going to create two different files and kind of put them together. Okay. What's expected? Really the big thing here is we want you to work through the basic steps, develop a proposed design, and present it to your clients through the building model. So for 2 units, my good friends for 2 units are going to be on the architectural side, basically working what I'll call the shell of the building. They'll work on the exterior walls, doors, windows, floors, roofs. They'll put some stairs and railings in there. Okay, and put some interior walls in there only to the extent they really support the core. So in almost every building, if we have stairs and hallways, yeah, you'll go through and you put walls around those sorts of things, just the essential things. You're not going to frame out all the offices, but at least around the stairway, you put in the walls for fire protection, things like that, or around the elevators, things like that. So not too much in terms of the interior walls. Okay. However, we do want you to go ahead and put a restroom in here. So go ahead and put in some restrooms. And as you're thinking about the number of people working in this building, think about, yeah, it's not sort of a single stall restroom. It's probably multiple stalls like we have in this building. There's probably at least 3 or 4 different toilets or urinals in each of the different restrooms to handle kind of the needs. Okay, and one of them should be ADA compliant. Now, when we get to that step, I'll show you there's some really cool components that actually help you. There's plumbing partition components that we can bring on in that make all of that very easy. You can just sort of say how many ADA stalls, how many regular size stalls, and it'll put those interior walls that happen between the different toilets. Okay, does a very nice job of helping you lay that out. So we'll show you where that is. Okay, in many buildings, these restrooms are located near the elevator and the stairway core. Okay, and they're often repeated. Okay, so some different things. We talk about this a lot in the B class. As you think about an overall layout strategy for your building, you can think about some elements as being ones that continue vertically all the way up through the building, like your elevator, and typically your stairways do that. For that reason, typically restrooms end up in that central core, and they're stacked on top of each other too, so that you have the same layout on all the different floors. Kind of an efficiency. Yes? Yes. Exactly. So the question is, will that also become the structural core? And yes, what will happen is, for example, if we put some like concrete walls around the stairway or around the elevator, that often becomes a structural core that gives you some lateral resistance. Also, we can use that to put beams on, so we don't have to put columns in that location. You know, they can put bearing walls. Yeah. So very common strategy. Now, in addition to that basic architectural model, we're also going to go and have you create a structural model. So what you're going to do is we're going to start with a structural template and put in some grid lines, put some columns on the grids, put some beams and beam systems in there, and even put some isolated footings in there. And if you're wondering about how hard that is, we actually did it in like the last 20 minutes of the last class session. We'll do it again today, but it's not so bad. It really comes down to, if you, for your overall shape and form, can come up with a good system of grid lines and levels, putting the elements in is not too hard. It actually sort of follows a very, very regular pattern that involves a lot of copying and pasting and repeating things. Okay, so we'll take a look at that some more today. But the idea is basic architectural of the shell, basic structural. Then finally, you're just going to share your design by putting these things on sheets. And when you put these things on sheets, because it's a bigger building, quarter scale, which we often use for residential buildings, probably won't work. We'll have everything either be 1/8 of an inch to a foot, or it might even have to be a 1/16 inch to a foot for some people's buildings, depending on how much space you take. But we'll plot them at a smaller scale. We're also going to put them on a bigger size sheet. We've been using 24 by 36, which is very common for smaller projects, but we can use 36 by 42, 30 by 42, which is E-sized and much more common for gigantic sheets of plans that we have on bigger buildings. Okay, so we're going to put our floor plans, we're going to put our elevations, we'll put a room schedule. We'll also go through and have the structural plans. Now, just because we know we can do it, we'll also go ahead and include a few 3D camera views to help illustrate our design. maybe like one nice exterior camera view. Again, you could put more, but at least one. And a couple interior camera views just to focus on some key features. So for example, if you have a beautiful atrium that goes up or a nice stairway that's in the middle of the building, that would be a great one to kind of put a nice camera on, just to kind of highlight all the design thinking you put into that. So think about a couple places as you're designing that might be your real kind of, really nice camera shots. Don't need too many of them, just a few usually sell the idea. Okay, the structural system, we'll do a 3D overview of that. But sounds like a lot of pieces, but they're all incrementally small. This is one where clearly, if you sort of follow along and kind of keep a pace with it, nothing about this is all that hard. But you got to sort of keep up with it because you don't want to be doing this all the Tuesday night before it's due, because it just gets to be a lot of stuff that last night. Okay, that sort of makes sense? Or let me pause and ask for questions about that stuff. So everyone's going to be doing the shell of the building. Make sense? Okay. Continuing. For people who are going for a little bit more, on the architectural side, you're going to add some interior things. You're going to add some interior walls around those meeting rooms and kitchenettes and stuff like that. You're also going to add some furnishings and casework. I'll really say in the major public and collaboration spaces. So here's the big thing. No one wants you to go out and furnish every room. Okay. In fact, if you have a bunch of conference rooms, I'll show you a trick where you can sort of put a layout in one and copy it to all of them. But no one really expects you to outfit every conference room or every seminar room. As long as you do like one of each of the major spaces and show what the furniture configuration is, we can use this grouping and copying technique to copy the furniture around. But you don't have to furnish everything. Don't think about that. But there are probably a couple of key spaces. If your cafe space is a really nice space and you think people will gather there, then it might be good to put tables and chairs in there just to sort of illustrate what it's like. Okay. And as you're thinking about this, definitely use the component libraries, the online sites, basically find things that are readily available. You can, most of you have demonstrated great creativity with being able to find good Revit City components and use them very nicely. So continue with that pattern. Okay. Plumbing fixtures, we'll put some nice toilets and sinks in that bathroom just so we sort of get a sense, as well as the kind of subdividers. On the structural side, my good friends who are going for 3 units are going to take their structural model and just push it a little bit further. What we're going to do is we're going to add in just a few things that are necessary if we were going to go through and do our structural analysis. And I'll show you how to do the structural analysis. You won't be responsible for doing one, but I'll show you how it works. We're going to put some boundary conditions at the bottom of all the columns, just making sure that the point loads are distributed and resisted. We're also going to put some loads just on the floors. So we have some office building live loads. We have some special heavier loads in corridor areas, but we're going to put some loads on top of the structure. And all this information would allow us to take it to an analysis package and ultimately size all the members. Okay, so that's my 3-unit friends. My 4-unit friends, they have just a little bit more to do, but it's actually not hard. Here's what we're going to do. For my 4-unit friends, we're going to take on the issue that a lot of times for a design, we want to put a couple options in there. So the idea is, for some aspect of your design, it really can be any aspect of your design, there's kind of the way you're proposing it, and then there might be an alternate way to think about that. And that might be just sort of alternate arrangement of some interior walls, it might be some different furniture, it might be a different sort of canopy or some sort of a facade feature, just something that you want to do that's different. Now, I'm not proposing that you do like a complete major redesign of something, just something where if we had a camera pointing, people could say option A, option B, and choose between those two different things. So you'll design something like that. The good news is you've already done option 1. You made your option. It was the whatever you were proposing. So what we're going to do is just for option 2, we're going to find that room or that canopy or that one area where you're going to create an alternative. We're going to do something using the design options tool to create a second version of that one area. And then we're going to go through and just set up views so that they show the primary, which is your first option, and your option. So you can put the two side by side and people can choose. Okay. I'll spend some time showing specifically how that technique works. Okay? But it allows us to basically have a single model that has a bunch of different choices in it, which is really kind of a cool technique. The final step is this architectural and this structural model. They're hanging around as two separate Revit models. For my 4-unit people, we're going to take that. We'll do it for everyone can do it, but only my 4-unit people are responsible for this. You're going to put it into something called BIM 360 Glue. And in BIM 360 Glue, it'll merge all those models into a single model that we can walk through. Okay, and we'll merge them together, and in that merge model, we're going to have you navigate around, put a couple camera positions in there that we can navigate through the model and kind of just get the experience of walking through it. Okay, so that'll be the final step. Yes?
So we're being asked to create the same building in 2 different files here, it sounds
Yes.
like. Is there a great way for us to be able to design the structure in one and then separate them, talking with my water model, into the 2 disciplines that you're talking about?
Actually, what we're going to do, the question is, we're asking you to create 2 different models. And is there a way to really kind of set them both up that is easy, convenient, all that kind of good stuff? What we'll demonstrate doing today is we'll start with an architectural model, and what we'll do is we'll create a structural model that's blank. We'll link the 2 together so you can see the architectural model inside the structural model, edit some things in the structural model, then we'll link the structural model back to the architectural model. So you can then see the structure inside the architecture. So this is the way we do it in industry. You kind of have these 2 models that work in parallel, but what happens is they stay coordinated by just having them linked between things. Okay, and that sounds much more complicated than it actually is. So when you see it, I think you'll see that it's not too bad. It's like basically having this transparent layer that lets you see through into another model, but it puts 2 different realities on top of each other. So hopefully we'll get that question answered today. Okay, enough yakking about the assignment. The important things for today is just kind of be thinking about it. Be thinking about what this workspace of the future could look like. And on a high level, just think about what 150,000 square feet looks like. Because it's kind of a hard one sometimes to get your head around about really what that looks like. Okay? So let's go ahead and with that as a little bit of background, get ourselves started today. I want to start just with the whole notion of space planning, because space planning is kind of a good place to start with this. Just as you go working, as we start thinking about trying to allocate different spaces, it tends to be useful just to have an overall plan in mind. So we looked a little bit last time about how we could use conceptual masses to actually figure out what an overall shape and form of a building looks like. Okay, well, maybe I'll start there, and then I'll do some space planning. So let's go back, and I'm just going to go back to Revit, and we'll start by just kind of creating an exterior form for a building. Again, this technique I'm using of using mass forms isn't something you have to use. I just sort of like it because it gives me a really quick way of trying to figure out if I want a 3-story building that's 180,000 square feet. I can try and figure out what 60,000 square feet on a floor looks like, or I can try staggering the building a little bit and kind of just get a sense of, what this might look like in terms of how I'm going to come up with 180,000 square feet. After I come up with how much level floor I have on each level, then I can start saying, okay, for that, how would I divide that into conference rooms versus lobby versus offices, and just kind of come up with a budget for yourself. So I'll start this out by just going to the architectural template. Again, that's where we're going to start our architectural side of the world. So here is the beginning of the experience, and in this environment, let's just kind of set up some very basic things. Again, I'll usually go through and set the environment. Where is it going to be? Just because that'll help us out as we keep on working. So for my location, last time we were in Chicago on Wacker Drive. Where should we be today? How about someplace outside the United States?
Nicaragua.
Do we have a city in Nicaragua?
Leon.
Leon is E? Like that? Or like that?
With a D, yeah.
Okay, Nicaragua. Okay, so this will do a couple things to me. It's going to sort of force me to think about north and south a little bit differently, or at least think about where the sun is a little bit differently. Ah, we're very close to the equator.
Yeah.
Very good. In that case, there's a whole separate things in terms of like sun angles to sort of worry about. Very good. We also have a little bit of weather. Let's kind of see what your weather is like. You are pretty hot throughout the year here, so check out these temperatures. It looks like, at least in Fahrenheit, it's around 90 degrees or some variation thereof. Pretty much steady state through all the year. I would like this environment, actually. I liked Singapore, too. It was a very kind of steady state sort of thing. So right around 30 degrees?
Yeah.
A little bit higher. Throw it in there somewhere. I'm very bad about that Fahrenheit. Okay, but very good. Okay, warm weather. We might want to think about this. Some interesting things will happen here. It's warm. Our building will have to worry about cooling quite a bit. So we'll have to think about shading and how the sun's hitting the building. Having walls and walls of glass with no shading probably wouldn't be a very good thing. Okay, we could also think about in our building, the widths, if we wanted to have any sort of natural ventilation or take advantage. It may be so hot that it's impossible to kind of think about that, but we can try to incorporate that into the design too. Okay, so we are here in Nicaragua. Let's go through and also set up for ourselves some elevations. Again, this is all part of just what I'll call just coming up with a framework for understanding the design. Yeah, it's nice to, and we'll do this on both sides, just establish what the levels are going to be and be in coordination about these things. So I will go through and say, oh, last time we decided around 13 feet was pretty good. I'll just make it 14 feet today. And I will also go through and add just a few more levels to this. So I'm going to say level. I'm going to use the pick tool. The pick tool, again, will let me go through and choose something to copy, as well as enter an offset so that I can really quickly come up with level 3. And finally, roof. And again, if you prefer metric units, you should work in metric units instead. Do with something that's more convenient and comfortable to you. So in the assignments, I should actually write down how many square meters that is. Divide by 10, more or less. Okay, so we have our levels. We're looking pretty good. We are ready to start designing our building. So let's go through, and again, what I showed last time as a starting point was I just went to level 1, and I just came up with an approximate footprint of the building. Again, I'm going to do this using masses to get started. You don't have to. I'm starting with the architectural for right now. Okay, so I'm going to say in place mass. I'm just going to call it my building form. And I can do this in a number of sections, or I can start by drawing. I'm going to guess it's going to be about, let's say around 120 this way. Going to come down this way, maybe about 40 some odd. Come over here. I'm just going to make a little L-shaped building. Okay, so that thing I've drawn so far on level 1, you'll see it's hanging out here on level 1, is just a profile. It's just a series of lines that connect together. If I go to 3D, you can sort of see it's lying there on the ground. There it is. If I now, I'm still editing the mass. If I choose to modify and I select the profile, I can say create a form, whether it's a solid or a void, will depend on how you're kind of working, but I can make it. You might see that it already has some sort of a height to it. It has a height that guessed of around 40 feet. If I want that to sort of match my 14 feet, sort of increments, 3 times the 14 is like 42 feet. I guess my building is tall right now. I can just make that 42. Or I can stretch it up and down. Notice that if I go over to my elevations, it's over there too. So if you want to stretch it up and down here, you can do the same thing. Oops. Now, that's an interesting thing. What I've just done, accidentally, I've actually just grabbed an edge. So what I just did there, I don't think is right. I think I just sort of sloped something down. So I'm going to say, don't do it this way. So let's come on back, and I'll just choose the surface. And I'll say make that 42. Okay, as we get going, we can say just let's finish that mass. You might be wondering now, how many square feet are in that mass? To do that, what I'll do is I'll take the mass, and I'll say mass floors, and I can turn on some mass floors. Actually, I'm going to leave off level 4, because level 4 is actually the roof. Now, some people have asked about if you want to include atriums or things like that, and we can. You can get into here. If we create separate masses, I can give different numbers of floors to each of the different masses. So, for example, if I didn't want to have, maybe I'll demonstrate this. So in the main part of the building, I'll have the 3 floors there. And if I choose this, you can see so far, what do I have in this building? So far, I have about 220, or no, just 22,000. That's the gross floor area. 22,000. Yeah. Small building. Okay, I'm thinking it needs to be much bigger than this. So I'm going to make it, I'll pull it out a little over here. I was shooting again for somewhere around 60,000 square feet on my floor. Let's stretch it out here. That probably got a lot bigger. 188, 177 altogether. Actually, we're pretty close in size to what we need right now. What I was going to address was the whole issue of, well, what if you actually want to go through and have separate amounts of floors or in different parts of the building and stuff like that? And you can do that. Let me zoom on in there and kind of show you what that might look like. So for example, if I wanted to have a big multi-story atrium here on the end of the building, I might push that back a hair. Then what I'm going to do is go back to the mass. I will, on level 1, see if I can draw another rectangle in here. Okay, for this rectangle, again, I'm going to make a form out of it. Oh, actually, I take that back. I've got to do this a little bit differently. Bum, 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 bum. Let me open up this mass, get rid of my form over here. My problem is every individual mass has the same mass floors in it. So what I have to do is actually, for the second piece, create a new mass. So let me come on over here. I'll say another in-place mass. I'll just call this the atrium mass. And I'll finish this over here. Come back up, finish that form, stretch it up. The reason for creating the 2 different masses is this now gives me the ability to have different mass floors. So if I want a first floor, but I don't want a second or third floor, I could have that. Or if I want to have a first floor and a third floor, but without the second one, I can do something like that. So you can sort of aggregate things together in different ways. So I have mass over here. I have some mass floors over here. Because I've now created 2 different masses, though, I can't just sort of select a single one of these boxes and figure out the total amount. What I might want to do is actually create something called a schedule of the mass floors, and that will give me the total across everything. So what that would look like is, I don't have any schedules defined right now, but I can say, let's go ahead and create a schedule. Schedules show up under the View tab. And I guess we've always provided you with the schedules. We haven't had to go through and create very many new schedules so far. So how we do that is under the View tab. It's just another view of the data. We can create a schedule of some item in the model. say schedule of quantities. Let me give you a second to catch up there if you want to follow along. So again, under the View tab, we're going to the Schedules tool, and we're going to do a schedule or quantities of some element, and we can choose what we want. Now, if you don't have access to that yet, you might still have your mass open. Just go and finish your mass, and then you should have access to the View tab. But are most people okay? Can they create a schedule if they want to? Okay, if you want to, then say schedules or quantities. And mass floors is one of the things I can create a schedule of. Here's masses, and there's mass floors. So you can now put in which fields you want. And oh, I'm going to put in, what do I want to put in? I'm just going to put in the floor areas. I could also put in the mass family and type. Let's put that in there. That's just going to tell me which one it came from. Say OK. Yes?
So I just have a question because I didn't see how you did it. When you add another mass, do you need to join them together, or can you just put them side by side?
So just side by side is fine. If you join them together, then they would sort of intersect, or they could have a relationship. In my case, I just need them side by side. Where you might join them together is if you were cutting one with another to make like a void or something like that. Yeah, then you would join them together.
But then does that mean they're good? Or no, yeah.
It's tricky. No, yeah, okay.
Once you assign them, like then you can create a word.
Well, I'm trying to think. It could be either way in terms of creating that wall in the middle. Yeah, what we're going to again find is that with masses, I just use them as a starting point, and then we start getting literal with the building elements. Yeah, pretty quickly. So here we see the different sort of floors on the different sides over here. If I wanted to put a total on here just to keep track of what's happening, I could say put a grand total in there. And then I have to say what to total. Again, I'm going to total the floor area. Give that a total. So you can say I have about 172,000 right there. Let me try just tiling these windows together so we can see them all together. I'll tile. And I can get rid of some of these. That one. In the south elevation, I'll get rid of, just so I can tile them together. Okay, and the only reason I'm creating this view is just so I can see that schedule at the same time. So as I'm looking at the total over here, the 172,000, if I now come over here to this mass and you push it around, you'll sort of see the total updates real quickly. And again, this whole notion of just using masses in this way is really just the starting point. I'm going to keep on reinforcing, don't feel like you have to be using masses for everything. The one time you have to use masses is for my good friends who want to go through and create walls that aren't vertical. They'll need to create masses just because that's the only way to create a non-vertical wall. But for the rest of us, just the idea that you're actually sort of just figuring out what the shape and the form is enough. It's a good starting point. Although we showed you last time, use it to start generating building elements. Okay, so I have something that looks pretty good over there. Let me kind of expand it up. Just so we can start thinking about this building and how it's oriented, let me just show the sun right now, since it is sort of a unique environment. Let's just take a look at what that looks like. The sun is actually down here at the bottom. We can turn the sun on. We've sort of played around with that a little bit relative to rendering, just so we could have the sun show there. But if I say sun path on, let's say use the specified project location. Okay, there is the sun right now. You can sort of see that at this time it is relatively high in the sky. Let me zoom on in there a little bit. If I change the date, for example, for March, you'll see it's still relatively high in the sky. In fact, even though I go to June, it's still relatively high in the sky because we're so close to the equator, since we have a very small latitude here. Okay, so you can do this, you can take a look at this, but generally what this is going to mean is that, for the most part, as I think about this building, the south face and the north face are never going to get very much direct sun. It's almost always going to be somehow in the sky. The east and the west faces are the ones that are going to have more of an issue with the sun coming up and the sun going down in the morning and the afternoon. Okay, but just a little bit to think ahead to as you start thinking about what your facade's going to look like. Yes?
Sort of silly question.
What's that?
We're expanding our floor plans, noticing that you might have to move cameras so you're not running into them, the elevations.
Correct.
My
Oh.
east and west are not moving. No one else is having that problem. Move on.
No, let's show you what that is. It's just really in all of these different views. See what's coming up over there. See, I've made my big building and these cameras are kind of floating around in the center right now. So my east and west may not be, appropriate, where we think the east and west elevation are actually sort of cutting through the building. We always get into this fun discussion about whether an elevation is any different from a section. And in some ways it's not. It's just sort of a cut thing. If you do this, if you move the marker, that's the marker. See if I can drag that over. What'll happen is, oh, actually, it's making a liar out of me. Try this again. Usually what happens, what I always think of happening is when I move the marker, try this again. I think it should move the camera with it. Let's see. Nope, it's not. Okay. Things change, but that's okay. I'm going to move the markers out just so they sort of look like they're outside the building. Okay, but the key thing is actually for each of these different markers, let me zoom on in so you can sort of see this better. For each of the markers, there is an arrow which points at the building. Oh, now it moved. Okay, now I'm confused. This blue line actually represents the cut line. So if you move that back, then your markers and your cut planes are sort of in sync with each other. So again, if I move that blue line back, then it'll be on the outside of the building. Okay, but this is definitely an issue with these bigger buildings, is that sometimes the elevations don't show everything you need them to. Now, it's still not showing everything I need to. For example, if I go to the east elevation, you'll see it's showing some of the building in there, but not quite everything. And let's see if I can show you why. Okay. There is the building. Let me go ahead and crop this view. I'll turn on the crop and say show the crop region. Now I'll go back to the camera. And on the east side, you'll see that actually has little blue dots on the end. So I can sort of adjust things to sort of be where I want it to be. So if I want to crop it in, I'm having trouble grabbing the blue dot. There we go. Over here. So if you crop the view, then you get those blue dots, and you can kind of adjust that. So again, on the north side here, if I say I want to crop the view and show the crop region, what will happen is now, for the north side elevation, it'll show the proper distance, and it'll show what's happening there. Looks like it's actually being pretty smart in that when I'm cropping, it's trying to crop it so that it gathers the entire extent, which is probably smarter than it used to be. Okay, so we're going to start out just by kind of looking at our building here. Our building is not looking too awfully bad, but we're going to want to do a couple different things to it. We're going to want to think about it architecturally, and we're going to want to think about it structurally. So let's kind of think about it from both those different aspects. Now, just to get you started thinking about your space planning, because on this building, since it's 3 floors, I have around 60,000 square feet. Let me go ahead and open up one other file that you may or may not find useful. It's just an Excel spreadsheet, but there's nothing special about it. It is just a document to hopefully help you get started. Let me go back to 11. Space planning budget. See if we can open this up. Again, this is just an Excel spreadsheet just to help you kind of do your accounting. Well, that's not a very good looking message at all. Let's try again. What's going on in here? I just have, again, a simple Excel spreadsheet. What I'm trying to do is, this was originally designed around the whole idea of doing a university building, But the idea is you have some different spaces, you have numbers, you have an approximate size, you kind of tally up your area. The reason we're doing this is really just at some level, just kind of keeping track of 150,000 square feet is kind of a hard task. So you can think about, for example, if you want to have a nice conference room, for example, like the one that's next door here in the blue atrium. Okay, that room we know is approximately 20 feet in this dimension. Okay, let's think about it in the other dimension. It's maybe 20, maybe a little bit further. I would guess that maybe that room is sort of on the order of 20 by 22 or something like that. So if I want to say that there's a conference room, at least on the order of, I'll say a big conference room. Let's say if it was 20 by 22, about 440 each. So I'm going to put a certain number of those, or maybe I'm going to put 6 of them on the first floor. Just keep track of it. In the same sense, conference small. If I think about those little rooms where the project working studios that are down here on the first floor, on the second floor, those are more on the order of like 8 by 20 or 10 by 20, something like that. So maybe I'm going to have 10 of those, and I'll say that they're going to be 10 by 20. So just be keeping track of things. What you can do is go through and in your spreadsheet, not only keep track of your program spaces, but you could also then keep track of the extra 25%, just so that you're, not penalizing yourself. Cafe is always sort of an interesting thing. Like, how big do you think Coupa is? That's always sort of a funny thing for people to estimate. How much space do you think Coupa actually takes up?
Including back of house.
Including back of house. Well, ignore the front of the house right now. Just think about like from the time you walk in that glass door to the back of house. Yeah. Is it as big as this room? Yeah. Girish says no. Okay. What do you think, Girish? It probably is about half the size of this room. It's amazing what they really compact in that very small space. So when you say cafe, if it's 20 by 20, we can look on the plans and sort of see they're probably lucky back in there. So for the food prep and all that, there's probably one. If it was 20 by 20, they are lucky. Again, you don't need a huge amount of space. It's not a 4-star restaurant. However, think about all this cafe eating space. I always sort of find that there's not quite enough space to sit down around there. Okay, so I would like some more there. And also I might want to have some eating outdoor space. Now realize the same rule applies that we applied for your house, that anything you put outside that's uncovered or is at least 50% open, that's the best way to express it, doesn't count against your square footage. So roof terraces, kind of covered porches, balconies, all that stuff doesn't count against it. So go ahead and use those freely because you can take advantage of that in our nice indoor-outdoor environment. Okay, so just be thinking about doing some sort of budget. Again, you're not required to turn it in, but I think it may just be helpful for you just to try and think about where all your space is going. Okay, if I actually did have some hard-walled offices in there, let me say like an office. So how big is a good size office for, some manager working for a high-tech company, something like that? How much office space do they need?
10 by 12.
10 by 12 is a pretty reasonable assumption. Okay, so we'll say equals 10 by 12. And you can think about how many of those actually exist. If there are like 15 on the floor or something like that, that's probably a lot. So don't worry about it. Just kind of, again, just keep track so that you sort of know where your space is going. Okay, let us go ahead and do this. Let's take our break now. When you come on back, we'll do a couple things to this building. We will go ahead and look at it a little bit from the architectural standpoint in terms of how we can take advantage of the regularity of the building to kind of make our process work a little bit better. We'll also start thinking about the structural side and how we link the files together and kind of get those two sides working. Okay, so come on back in 5 and we'll go through and take on those issues. Okay, let's go ahead and get ourselves started again. Let me put that back up on the screen for you guys. So a couple things I want to do in this next session to hopefully give you a little more power as we work with this. There's this question about really, once you have this mass, how do you now start making a building? And again, there's two ways to approach this, and I'm not wed to either one of them because they each have sort of advantages and disadvantages. If at some level you'd like to just work with this building and really say, this is the building form, and I want to just work with it as is, what you can do is, come on, zooming in here. You can, we have our mass floors. They're all looking good there. We can start converting these things into specific elements. So under massing and site, for example, you can convert mass floors into floors. So if you want to go through and convert things into, for example, this lightweight concrete with a metal deck floor, I can convert this floor and that floor into that. And when I say create a floor, what it'll do is it'll use the boundary of that mass and create a floor there. It'll create a pink line floor just like we're used to. So what it's really doing is just using that mass as a way of getting started, just to kind of trace the boundaries. This lower floor, I'd probably want to do something a little bit different down there. For that one, I'll go to the floor, and they have a generic floor, but if I know that it's going to be a 6-inch concrete floor, an 8-inch concrete floor, or something like that, what I'll do is I'll just edit the type, and I'll make a new type for myself. I'll call it a concrete slab. Let me call it like 6 inches. Give it a nice material. 0'6" of cast in place concrete. But get used to the idea that you're making materials for yourself. Concrete. Never feel constrained by what's in here. You can always make a new one. Okay. Notice that this floor, as I've made it, has some properties to it. It has some thermal mass. It has some resistance. That's going to come in later as we start doing energy analysis on our building, because you don't realize it, but you're actually creating an energy model for your building at the same time. So just all those surfaces will compute or change into surfaces we can analyze with.
Which type of joint did you choose for the?
Or floor? I just chose cast in place concrete. So concrete, cast in place gray. Okay. So now that I have that material, I can again say, let's choose this surface, and I'll create a floor with that. And again, what's happening now is it's creating floors. These floors are all kind of standard pink line floors. If I go through and edit the boundary, you can see it has a pink line, and we can go through and change it, do whatever we need to. So this whole issue of, for example, if I wanted to go through and create an atrium, I could go through and play around with all this work with the mass, or I could just actually do it on the pink line boundary of the floor. I know how to make an atrium. I could just go through and on this pink line boundary of the second floor, I could just say, you know, I just want to cut away that corner because it's going to be an atrium. And my pink line rules will apply. I need to trim it. Okay, and now that floor has only up to this spot over here. Now, you might be saying, but it seems like the floor is still there. Let me shade this so you can see it. But let me show you there's actually two different things going on here. There is this whole notion of whether it's, well, it's just temporarily on. Let me set it up so I can switch this easily. I'm going to go to Visibility Graphics, and I'm going to turn off the masses. That'll turn off the mass floors also so I can't see them. So now I can kind of quickly toggle between show the masses, don't show the masses, show the masses, don't show the masses. Okay, so what I'm really trying to do is just use this massing as a way of, it's like a form. I'm just kind of making things up against it. And again, if you're familiar with a lot of architectural tools, you can create forms in Rhino or using Grasshopper. You can create them in Fusion. We can do whatever we want to and kind of bring them in and then use those as the way to generate the walls. Okay. Another thing we showed last time, which is a handy sort of way to do this, is you can go through and take a wall, and again, you should always think about the proper surface. I'll make it this EIFS. You have the choice of, is this surface going to represent the core or the finished face? And I usually make it the core. And I can drop some walls on there. Now, making buildings this way is very, very quick, and it has a lot of advantages. But there is sort of a disadvantage to it. And let me see if I can demonstrate with the point or how that has a slight disadvantage and why I actually advocate doing it a slightly different way. So for example, on this face of the building, I could go ahead and put that wall. And now, as I'm going to go through and add some detail to the building, I could start adding windows. So I can put some windows in down here. Hang on, let me zoom on in so you can see a lot better. ZR, zoom in. I can put some windows in here. Okay. And if I wanted to do something similar on the second floor, I can come up here. But here's the issue. Oftentimes buildings like this have a very repetitive pattern from the different floors. And for example, if you look at Y2E2, you realize that the buildings on, or the windows on the second floor and the windows on the third floor, for the most part, line up. There's a little bit of variation in there, but for the most part, things line up. So as you think about working with those windows and starting to articulate your facade, you have sort of a choice. You know, how do I want to kind of get them to work their way and be similar on all the different floors? Because often you'll do some design work on one floor and you want to kind of copy it up to the other floors. So there's different ways you might approach that. You could say, hey, let's go over to the east elevation and try to line things up over there. Okay. But an even better way, and one that I'm going to hopefully get you used to sort of using because it's really very powerful, is to go through and think about doing this. As opposed to just sort of moving things around individually, kind of floor to floor, what you can do is actually copy those windows, and if you copy them to the clipboard, you can paste and align them to other levels. So we can, for example, put them on level 2 and 3, and they'll be there also. And there's some advantages to doing that, because it's really sort of quick. And if you have a very regular pattern, what you can do is really focus on one floor and say that floors 2 and 3 are probably pretty similar. Yeah. It could be that floor 2 and 3 are a little bit different, and that's okay. If on floor 2 and 3, I want to add just a few more features, for example, I could add some additional windows in here. If I want to copy those up, I can Control-click to get those and copy those and paste them up to level 3. So it doesn't mean that every floor has to be exactly the same, but you're going to find out there's a lot of things that tend to be the same across the different floors. When we go through and lay out that floor, the bathroom on floor 1, it's probably going to be very similar on floor 2 and 3. So what it makes sense to do is just get it all well laid out on one, get everything just the way you like it, and then copy and paste it up. Same thing. Often in a building like this, we'll start with the hallways. We'll sort of get the hallways kind of put in and put in some doors in the hallways and stuff like that. Again, copy and paste them up so you sort of get the advantage of doing it between the different levels. Okay. Let's kind of demonstrate that just real quickly over here. Let me zoom in. Now, even though I've created this thing as a hybrid, or as from a form, these walls that I've created, since they're vertical walls, really are just the same as though I had created them in the floor plan the way I normally would. So I can do all the normal things I'm used to doing. I can say I want to draw some new walls. I'm going to draw them on the core face exterior. I'm just going to make them go up to level 2. There's kind of it's almost like a debate or kind of a philosophical sort of issue about really how you should make walls. Should you make them go up from level 1 to 2, or should you make them go from level 1 all the way up to the roof? And the answer really is, if you think about how the model is going to get used, you want to do them however it's going to get built. So if they're going to build the walls from 1 to 2, model it that way, and then have the walls 2 to 3 and the walls 3 to roof separate. If they're going to do it all as a single piece, do it as a single piece, because you always want your model to match what happens, you know, when they build it. You'll find that when we do some 4D simulation and we sort of apply a construction schedule, you'll want to make sure that things are broken down the same way they would actually be taken to site and installed on site. Okay, so often, since I do a lot of wood frame construction, we do things floor by floor. I'll build level 1, put a floor in, build level 2, put a floor in, build level 3. But it really just kind of depends. Okay, so I have this. I'm going to go through and again put some more windows in here. And for these, I'll put some windows in. Oh, what I might want to do? Let me take these. Maybe I'll array them because that's kind of nice. Actually, as an assignment or as a challenge or something like that, kind of pay attention as you're outside the Y2E2 building today about how the windows are arranged and what the pattern is. There's actually sort of a very strong pattern to it all. They're not just kind of a bunch of them stuck in individually. We tend to have a lot of windows that are, oh, I'll call them ganged. They're sort of stuck together, where we'll have some windows that look like this. I have some windows that are 2 gang very commonly. I have some other ones that are more 3 together. Oops, I moved. Let me ungroup that. I ungrouped that by accident. Nope, I didn't. Okay, let me copy that. I'll make one that's a 3. And what you're going to find is patterns are actually a really good thing on a big building. They tend to work to your advantage. So if you have patterns like that and you kind of pay attention to Y2, you see it's sort of a combination of different patterns. But once you've established the pattern for one floor, you can kind of copy it up to the other floors. Let's go through and draw just a few interior walls. Again, as you're starting to work, you probably have some sort of a hallway that's in some specific distance. So let me go through and put a nice interior wall here. I'm going to say that, and this is a very useful technique, you can pick a wall and offset it. I'll make it like, 16 feet back. Okay. Then I can think about kind of creating the offices in the other direction. Maybe those are all going to be like 10 feet wide. So I can say 10 feet over, 10 feet over, 10 feet over. It's complaining because I'm hitting the windows because I didn't do a very good job of laying those out. But if I have a bunch of walls like this, I can use things like the trim tool to say, take that wall and trim all these walls to it. So you can just play games and just, you know, make this work much better. Let's go through and lay that out over here. I'll put those in the middle of that one. How about this? For this one, I'm going to have a big office there. And they could have 3 windows. Maybe for this little office over here on the end, I'll duplicate that. And they also get the 2 windows. Super. You can put a couple doors in. And again, I'm just sort of making it up as I go. But if I start to have a pattern now that I think might be good for all the different floors, super. Let's go ahead and copy it up again. So what I'll tend to do in this case is I'll go through and basically grab everything I think I might want. Now, if I had put desks and chairs in here, I could put those in. If I had put plumbing fixtures in here, I could grab those too. But I'm going to grab what I want. I'm going to take out a few things, though, because as I've grabbed, you'll see, I also grabbed the floor and the mass floor. I don't want to grab those or the views. Walls, windows, doors, no floors. Okay, those are the things I want. And I'm even going to do one more subtraction since that one goes all the way up. I'm going to take it out too. But I'll copy these things, and I'll paste them up to floors 2 and 3. I'll say delete the instances. I didn't change everything. Yeah. Not sure what it was complaining about there. But we have now the same level on 2 and 3. And not to worry, if on 3 it turns out that wants to be a big office, no problem. But it was easier for me just to do it that way to get started out with and go from there. So there's a lot of things you can do like this to just kind of make your life a little bit easier. We'll explore some more things on the architectural side next time. We'll look at, for example, how curtain walls go up the whole side of the building. We'll look at how the stairs and the elevators and the shafts and some of those things happen on multiple floors too. But for the most part, you pretty much lay it out on one floor the way you would like and kind of copy things up. And hopefully it does a pretty good job. But I just want you to sort of be aware that the fact that I created these walls either with the mass or just by drawing the walls around the mass is irrelevant. Either way, the walls are the same. So this wall over here that I drew and copied versus this wall which I placed on the mass, they're now the same. I could do the same thing to either one of them. So, I always use the mass really to help me understand to get started, but then I'll start drawing things individually just because it gives me more control, typically. Okay. Let us save this away. I've got my beautiful architectural drawing here. Well, not so beautiful, but it's a start. And I will save this away because we are going to think about the structural side of the world now. So save this away. I got my project. I'm going to put it out somewhere where I can find it. Like I'm going to put it on my desktop. Actually, I won't put it there. I'll put it in Glenn Katz documents because they would hate if you put things on the desktop around here. So I'm going to call this session 12 arc. Yes?
I just have a question. How do you introduce interior walls to the entire, all 4 levels at the same time? Or does it have to be by level?
You could do it across all the levels. You would just say go from level 1 up till roof or whatever level you wanted to go to. Yeah.
So I just open up any of the floor plans?
Yes.
And I introduce it and then I change.
And you change the top or the bottom constraint. Now, watch out when you do that because the question is, should you make the walls go the entire level or level to entire length or level to level? If it doesn't want to be built that way, yes, if they would actually build it in levels, you're better to do it level by level and just copy it. So it all depends. Like sometimes, often, many types of walls we just do level to level. Curtain walls are one that often they just do the whole facade at the same time.
Is it because of the intersection of the floor to the wall?
It's because later when we try to use the model as a building tool, they wouldn't insert all the floor walls on all levels at the same time. They would do it level at a time.
Okay.
Yeah, so you're just basically, you're setting up your construction people for an easier time to actually do their estimating and their planning. No worries. No, it's a very good question. This is like the philosophy behind BIM, and it really, always think about the last user of your information and what's going to be the most useful to them, because we can do lots of things that either make it easy or hard on that poor person. And yeah, if you think ahead, you're doing a good job. Okay, I got my architectural model. It's hanging around. Okay, let's close it up because I can't actually keep my architectural model and my structural model up at the same time. Or if we're going to link to it, let me say it that way. You can't have a model open both for editing and linking to it at the same time. It's either one or the other. So if you happen to have 2 computers, you can keep them side by side, or there's a lot of ways you can sort of try to finesse that. But for the most part, you have to keep them separate. I'm going to start our structure model just by saying, let's open the structural template. Here we are. It looks, in a lot of ways, incredibly similar. About the only thing most people will spot that's different is it says structural plan instead of floor plan. And these elevation markers look a little bit different. Okay, that's about it in terms of what most people will spot. But there's some things in the background that are a little more full-featured here. You might notice there's actually a view called the analytical model, which is over here in the 3D views. That's really useful for making a line model that we can take to eTabs or a structural analysis tool. Okay, so if you're in that world, that's going to come in handy for us. But let's talk now about how we get these models together, because, hey, you've created the architectural model. You don't want to have to recreate all this stuff. So let's think how this works. Okay, what I'm going to start by doing is just linking the models together. And how we do that is under the Insert tab, you could say, let's link to another Revit model. And when we say link, we can go out and find that other model. Where'd it go? There's Session 12 architecture. I'm going to leave it origin to origin. What that's going to do is it's going to make sure that your 0, 0, 0 point for XYZ and mine are all in coordination with each other. Now, sometimes they get out of coordination and we have to do a little transposition, but that's okay. But if you can keep them in coordination, your life is a little bit easier. So I'll say origin to origin. Okay. Now, so far, this may look incredibly uninteresting. Let me zoom to fit. I think it's in there. Go down to level 1. There it is. Okay, we do have something down there on level 1. Okay, but let's look at it in 3D. You'll kind of see that the architectural model, it looks a little bit incomplete, okay? And only because of the way it's sort of displaying itself to us. And it has this other interesting attribute in that if you click on it, it gets a big blue box. That is the look but don't touch box. Okay, so you can look, you can query, you can find out what the architect has done, but you can't actually change the architect's work. And vice versa. You'll appreciate that the architect can't move your columns and beams around, okay, since you're responsible for them. So you can always see the other person's work, but you can't actually change the other person's work. Okay, so now let's go ahead and get our worlds in coordination. Our XYZ corresponds with each other. The other piece, yes? Nothing at all? Go out to another view. Go to the 3D view and try saying zoom to fit ZF. See if anything shows up. In your architectural model, did you have any floors? Okay, because it had, not mass floors, did you have any real floors? Still nothing. Let me just take a look and sort of see what's going on. The question is, what if nothing shows up?
It's the same thing with me. But when I try to link to the map, it tells me that the link already exists.
Yeah, no worries. I think it's probably there. Oh, you're looking at the analytical models right now. Try this. Go to the default 3D model, which is right up here. Try that one. And there they are. Okay, what's happening is the analytical model for many of us is not showing up with anything in it just because you don't have any things that have an analytical property to them. So my floors probably were set to be structural, so they have an analytical shape to them. But if you are not seeing, just go back to the default. Uh-oh, did it go out? Oh no. Did it lose its power?
I promise I didn't touch it.
Yeah, no, that's okay.
No worries. I think it's just out of its power. Yikes. Well, follow along for now. Yeah.
Thank you.
Okay. So we're looking at this we can't touch. But what we do want to do is we want to make sure that your sensor level and my sensor level correspond with each other. So what I'm going to do is go to the south elevation and let's just take a look at what this looks like. I'm going to zoom on in. And you'll see that we have two different sets of levels in here. So let's talk about what's going on here. The level 1, 2, 3, 4 came from the architectural model. Okay. The level 1 and 2 are the ones that are in the structural model right now. I can tell they're from the architectural model because if I try to click on them, I get the big blue box. We want to get those two in sync with each other. So when I talk about level 2, I mean the same thing as the architect. When I talk about level 3, I mean the same thing. So what I'm going to do is I'm going to say, hey, I would like to copy the architect's levels and link to them so that if anything ever changes, we stay in sync with each other. And that's a really cool tool. Under the Collaborate tab, because we're going to collaborate with someone, we can turn on something called Copy Monitor. And if we turn on Copy Monitor, you'll see that we can say, what do we want to copy from? We're going to copy from a linked project, and then we choose the things we want to copy. So I'm going to copy monitor from a link. I will choose the linked project. Okay. Notice now I'm in sort of a special mode. I can tell I'm in a special mode because I have a green ribbon up here. I have the finish and the cancel. So it thinks I'm in the middle of doing something. And what I'm doing is I'm getting ready to copy things across. So I'm going to choose that copy tool and let's start copying. I'm going to copy level 1. Now, copying level 1 is really incredibly unexciting because they sort of are at the same level already. But that will at least link them together. Next, I'm going to go up and copy level 2. Now, level 2 will be a little more exciting because you'll see some movement. Level 3 will be creating a new level. Notice it's going to spin for a while. Okay. It doesn't look like it did anything because it put the new level 3 right on top of the old level 3. So I just have two things that are just right on top of each other. Let me get level 4 also. I think I just got it. Let's finish. Now you might be saying, well, I created level 2 and 3 and 4, but over here in my structural plans, it doesn't show me level 2, 3, and 4. So what's wrong? Okay, and the issue is when we copy, it just doesn't automatically create the views. But if you want to create the views, you can say view, let me choose structural plan. And I'll just choose 3 and 4 are the ones that don't exist. Okay, and now they'll show up over here in the browser. Okay, so we got two views that are sort of in sync with each other. So we are now ready to start working. Let's go ahead and save away our structural model just because we will want to. Let me say File, Save As, and I'm going to call it my Session 12 Structural.
Select green.
Yes.
It doesn't take me to the green.
Let us see what it's doing. Did you, after you click select link, did you click on the linked file? Let's see. So go through copy monitor and we'll say select link. Now try clicking on that guy. Now there, now you can go through and copy them.
How do you do copy?
You copy and we'll just copy level 1 first. Okay, then we'll copy level 2. Now we'll copy 3 and 4. And 3 and 4 take a little more time. Now, the reason I saved away my structural model is in just a few moments after I make a few changes, I'm going to go through and link it back into my architecture so you can see my structure inside my architecture and vice versa. Now, we will talk about this some more next time in terms of grids and how we lay them out. Let me just sort of put some basic grids in here now just so we can get started. We sort of did this a little bit last time. What I'll generally do is I'll put grids in each direction near the outside boundary of the building, but not quite on the boundary, because usually I want the skin of the building to be outside where the columns are. So what I'll do is I'll draw some grid lines. And again, we'll talk more about the philosophy of where you put them next time. But I can either draw the grid line, and I'm going to guess there's going to be one sort of about here in the middle, and one sort of down in here. Now you might be asking, how do I know they're going to be there? And again, this is that artistry of you just do it enough and you start to sort of realize there's sort of a pattern to it. And it's all going to get down to just the spacing and the dimensioning and what sort of feels right. But I'm going to try and come up with a pattern that'll cover most of the building with a fairly regular pattern of kind of beams. Put that back in there. Now in the other direction, I'm going to draw some grids here. Now for these grids, I'm going to go through and change the name just a little bit. It actually put 6 in there because I had to put 5 in there and 6 would be the next one. I'm going to put A in there. because now that I've had the A in there, the next one I create will be B and C and stuff like that. Now, a good way to think about grids is that offsetting tool can be used. So you can say offset, and I'll put it 30 feet away. I can sort of say, oh, this building's a lot bigger than I think. That actually turned out to be a pretty good spacing there. Almost by accident. That last one's a little odd. Now, for this last one being right on the boundary, again, there's going to be a discussion. The architect and I are going to have a discussion about really the positioning of my structural grid versus the position of the building. And it could go either way in terms of whether we move the outer boundary of the building a little bit or I move my grid in to accommodate the building. It's kind of a choice in there, you know, but there's no single right answer. We just have to get the two kind of compatible with each other. Yes, Brad?
You array a series of grid lines?
Yes, that would work too as opposed to offsetting. That's a quickie way of getting a bunch. Yep, so that's actually a very good way. Okay, now that I have my basic grid, let's just go through. I'm going to put a few elements in one area just so I can show you the linking back. Again, we'll explore this more next time. But if I go through and I say that I want to put a structural system in, and we'll also talk next time about the implication of sort of concrete versus wood versus steel. If I want to put in some steel columns, what I can do is either click on the location, zoom on in there, and I can sort of click on that location and click on this location. But what I advocated doing last time was if we can use the fact that the columns usually end up at the grid intersections, that saves you a lot of time. So you can say grids, oops, let me, even before I put the columns in, pay attention to the height issue because that'll get me in trouble. I'm going to say they go high up to level 2 as opposed to deep. Probably the most common mistake people will make is they'll have them go deep as opposed to up, and then they just sort of show up below the building, which have to adjust them. No worries. It's easy to fix. So I'll say, let's get that grid, this grid, this grid, this grid, and I'm going to get these grids in this other direction. And let me zoom on in there to show you. It's proposing putting a little columns in there. I'll finish that. Okay. And if I come back over to 3D, you should see something that looks like that. Now, just to finish up for today, let me do a couple things quickly just so I can show you the relinking. What I will typically do with something like this is I will start putting them in beams. And for the beams, I'll put them at level 2. I'll 3D snap because that way I can just snap directly to the column tops. Again, we'll show you some tricks for doing this a little bit quicker. And what we're going to find out is that our structural engineers like to copy and paste just as much as our architects do because it helps them too. So I can sort of say, let's copy. I'm going to grab all those columns and beams. I'm going to copy them in clipboard, and I'm going to paste them to levels 2 and 3. Actually, 3 and 4. Structural engineers have a different view of the world, so they think all those beams and columns are on level 2. So it's going to be on levels 3 and 4. Okay, let's save that away.
Isn't there a tool where you can just do the entire grid of beams? Like,
there are some closer ones. Yeah, no, in the.
you do the whole system at once?
There are some automated like extensions that do that. Okay, not built in right off the bat. Like built in, we can put the beams on grid lines. What else? There's some shortcuts. We'll show a lot of that next time. Okay, but let's finish this off today just by showing how you get these things back together. I have my architecture, I have my structure. Let me close my structure. And for your last thing today, Let's get these two models back together. So I'm going to go back and open my architectural model now. And you might say, okay, my architectural model is hanging out here. It looks fine, but I don't see that structure. So how do we get it back in here? What I have to do is insert and link. And I can link the structure back in. And when you link those two things together, you see now I have the architecture and the structure together. The structure is look but not touch. I can touch my architecture and vice versa. So this is the essence of how we keep the two things in coordination. But not to worry, I would say as you go working, I usually start by kind of getting my basic architectural form down. Just because I'm actually a civil engineer. I graduated in structures as an undergrad. Yeah, I tend to do the structural system first and then go back and finish the facade. Okay, just because I like to have a good clean structure and then I'll make the facade match it, something like that. But again, whatever sort of algorithm works the best for you, because you're going to sort of think with both sides of your brain in this assignment. Okay, so whatever order makes sense. Okay, let me pause there. We're going to wrap for there today. Any questions before we break for today? Nope. Feeling generally good? It's a lot of stuff to absorb, so some of it is just you have to kind of dive on in, try and practice and all that type of stuff. So here's what I'd advocate doing. Even though the assignment's not due, for 2 whole weeks, you still got a long time to do that. Go ahead, and even if you don't know what your ultimate design is going to be, try just practicing with, make some dumb little box structure, put some floors in, put some columns in. Just get the mechanics down so that you feel good about the mechanics and they don't become a stumbling block when you have your beautiful design. Okay, so just try and do some practice stuff, because if you can, then you can come to office hours tonight or beginning of next week, take advantage of all the help and just sort of get yourself ramped up towards your design. Great, okay, let us break for today.